Hi, this is Arthur for a Tezos Dev Update on January 12th, 2018. So with the new year, there are four more people now working on Tezos, and one of them is another programmer. There is now an office manager who's helping the team scale, grow, actually grow out of the current office space. The team has been looking for a new office space as it's currently overflowing this one. That's exciting. And three programmers, three talented people. So right now they're all getting to know the code base. It can be a little bit daunting at first. Fortunately, one effort that the team has been doing for the past few months is starting to pay off, and that effort has been writing documentation. I uploaded that doc to a website. You can go to doc.tzalpha.net, and I'll put the link in a comment. And there's two kind of documentation. One is just this low-level comment in the code, but also some more high-level tutorials and explanation on how to contribute to this code base. And so we're going to be putting more of that documentation. One of them is currently working on Mickelson, and so working a little bit on some of the works that Milo had been doing on Mickelson, in particular those big maps, which can be used for creating subtokens. One is working on the endorser. So, in Tezos, you have the client, which is how you can communicate with a node, make transactions. You have the node, which connects to a peer-to-peer network, receive blocks, forms a blockchain. And you have the Baker endorser, which are the processes that participate in the proof-of-stake algorithm. And so the Baker and endorser were working, but they were not as high quality as the rest of the code. And so we're rewriting this part, which is endorser and Baker, starting with the endorser, which is slightly easier than the Baker, and then the Baker, which can be a little trickier because of the random commitments that it needs to make. And a third new team member is working on more test coverage for the code. And I always insist on test coverage, but that's absolutely critical because in terms of functionality, you can use the AlphaNet, you can make transactions, you can run smart contracts. This is there. What's really important for Tezos to launch is to have this very, very good test coverage that there can be high level of confidence that bugs are not going to be found once the network is launched. Now, that being said, we had an advisor over last week, and he had a very interesting suggestion, something to consider that I've been thinking about. The idea would be to try to have a beta net, which is same as the AlphaNet, but with real parameters, and people could opt in into this beta net. So using using the real private keys and real public keys, opt in the AlphaNet to make real transactions, but possibly have some limit on the amount of transaction that can be done in the block, so that in case of a bug, the damage can be limited. So I think that would be interesting because there's some value in having a ramp up to a launch where you don't immediately put like billions of dollars at stake just with the press of one button. I think that's an interesting approach, something to think about and consider from a technical standpoint, which is how I'm looking at it. It's not too difficult to do that, and it's about the thing that we need to do for that is essentially changing the constants from the proof of stake, having a little more validators, and writing a piece of code to cap the transactions in the block. Something I'm looking at. Other thing of interest is the blacklists. So in any proof of work system, you have a fantastic anti-spam mechanism. If you get a block in Bitcoin, you immediately know that it would be very expensive for someone to bluff, right? You get a block which passes a proof of work, very cheap to verify. In proof of stake, you don't want it to be expensive to create blocks. You want that to be cheap by design. This is what you're trying to obtain. You want it to be expensive to cheat, and you want it to be expensive to lie and deviate from the consensus algorithm, but you don't want it to be expensive to participate in the consensus algorithm. And right now, in any proof of work system, it's not expensive to participate in the consensus algorithm for miners because they receive a reward, but it's expensive for the entire system in the form of inflation. So you still need to deal with spam, and when we were doing this is with blacklists. So if we have an IP start sending bad blocks or an identity starts sending bad transactions, then they can be blacklisted. So identities in Tezos there's just this public key that passes a very small proof of work test. but it's actually tunable so that you can, when you connect to the network, you can choose to mute nodes which don't have a high enough score in their node, in order to avoid being relayed bad transactions. So that's one thing. And we used to have blacklists, but now they're implemented a lot more smarter so that they don't blow up, which means, for example, that the way that blacklist is implemented for IPv6 is in the form of a patricia tree, meaning if you have many bad IPs from one subnet, this gets compressed at the blacklist level. So that's a pretty good optimization. No such optimization for identities, but for identities, essentially, if you start blacklisting too many identities, you start raising the difficulty threshold that you require. And I assume that large nodes, large makers in the network, people who are invested in making this project a success, will be basically looking for expensive, high difficulty identities so that they have some stay in the network. Regarding the AlphaNets, we used to have underpowered machine used as bootstrap node, which made it hard for folks to initially connect to the net because they wouldn't find peers. So we replaced those with beefier machines. So now it should be easier to connect and sync with the AlphaNet. And I'll end with my usual note: please connect to the AlphaNet. Use the network. The more people use it, the more people bang up on it, the more we learn. Until next time, thank you.